Alright guys, this is the first lesson for chapter 6. You do have a quiz on Thursday, just so you know. The quiz on Thursday covers double angles, double angle identities, half angle identities, and this stuff. Okay? Quiz on Thursday. Double angle, half angle, this stuff, yes, you will. You don't have to memorize the half angle identity. I would be very familiar with those double angle identities though. Alrighty, so today's notes. Chapter 6, Section 1. A lot of this stuff is just sort of review. Oh, you okay? I'm sorry.
Will we have a review assignment?
No, we don't. No. It's just more of this. That's why you have those assignments, to study those.
We don't have a slash assignment for that.
You will today. You can pass it back this hour, I promise. Alrighty. Functions. Definition of a function, usually it talks about, one element of the x matching one element of the y. Really means just don't have any repeats in the domain. No x's can repeat. One-to-one function means that every y value is used only once. Now, you guys are familiar with the vertical line test, and it tests whether it's a function or not. The horizontal line test is going to tell you basically if it's a one-to-one function, or it's going to tell you also if the inverse of the function is a function. So that's kind of what's happening here. We've got g of x is x squared, makes a parabola. Horizontal line test, they're trying it out. It looks like it touches in 2 places. So this is not a one-to-one function. F of x is x cubed, and this is a one-to-one function. It passes the horizontal line test. No matter where I put my pencil, it's only going to touch it one place at a time. Bless you. I realize the x-axis looks like it touches it in more than one place. Just know that this right here is forever increasing, and it only actually touches right there at 0, 0, and this is forever decreasing. So it doesn't really touch it more than one place. The bottom. The inverse function of a one-to-one function f, that's the name of the function, f, is defined as, and I realize the font makes it kind of hard to see this, it's actually f, and it looks like it's raised to the -1 power. That's the notation they use for inverse. That means inverse of f. And how you find the inverse of a function? Here's the mathematical fancy way to say it. Basically, it means swap the x and the y. You just change places. The x's and the y's get switched. This is all review. Next page. Summary of inverse functions. In a one-to-one function, each x value corresponds to only one y value. We just said that. And each y value corresponds to only one x value. We just said that. If a function f is one-to-one, then f has an inverse function that looks like this. We just talked about that. The domain, the x's of f, would be the range for the inverse. The range of the inverse is the domain of the f. Basically, you're swapping your x and the y's. That's what that means. The graphs of f and f at -1, so the function and its inverse, are reflections of each other over the line y equals x. So mine has color. I know yours doesn't because we don't have a color copier. But this little guy right here represents f at x. This little guy right here represents its inverse. So you can tell that those graphs are flipped over, they are reflected over y equals x. Bless you. There are steps below for how to find the inverse. And actually, these are super duper detailed. You guys probably don't even need this much information. This is like 8th grade steps. You replace f of x with a y, because those two mean the same thing. Then you interchange, you swap the x's and the y's. Then you solve the equation for y. Then you replace that y with this notation. So those are your steps. I would put a star or cloud or something so that you don't lose that. Here's what's new for you. It's in bold. Note, we often restrict the domain, the x's of a function, that is not one-to-one to make it a one-to-one without changing the range. Here's what that means. we've got x squared here, makes a parabola. This is not a one-to-one function, but I need it to be. So what we're going to do is we're going to restrict the x's so that all of the x's are true only if they're greater than 0. So that now that I only have this half of the graph, I'm going to reflect it over y equals x, that line right there. I'm going to reflect it over that, and it's going to put it, I need a different color. Where's my green one? Oh, there it is. I'm going to reflect it over that line so that now it looks like that. So this green one is the inverse. So the main point that I'm trying to make here is that they're going to limit the domain so that it only goes so far on the graph. That's the whole point of that page. There are restrictions. Next page. And it looks like a lot, don't panic. Just look at the top half. It's talking about sine and arcsine. And you guys actually have numbers here, I know. I didn't get those filled in on the color one, sorry. But you've got x's and y's for the inverse function. You guys know that the regular graph of sine, for me it's in red. It's this red line right here, right? You know that that's sine. The inverse, once it gets flipped over, this green line, looks like this blue line. Problem is we need this to be a one-to-one function. So what they're going to do is they're going to restrict the values for the range so that they are only between negative pi over 2 and positive pi over 2. That's 90 degrees. Negative 90 degrees and positive 90 degrees. So the graph only covers from here to here. They're restricting it. So this is the inverse. Cosine kind of works the same way. Cosine's this one here in black. The inverse is the one in red. They only want to make it a one-to-one, so we only want to use the domain that's between, or the range that's between 0 and pi. 0 and pi. That will make it a one-to-one function. And then I've lost my tangent page somehow. I don't know where it is. Flip it so you get to your tangent page. I'll try to find mine. There it is. Tangent are the red ones that are up and down. You guys remember that? Notice for the inverse, they only have one little S curve because they have limited the range so that it's only between negative pi over 2 and positive pi over 2. So all of these little limits that you see, that's what you care about. That's what's important. This next chart is on page 265 in your textbook. And it's got the functions listed, all of the inverse functions. It's got the domain that's allowed listed. It has the range that's listed. What you're really going to care about is quadrant, probably. So for sine, you're going to use the first and fourth quadrant only. And sine's reciprocal function, cosecant. That's true for him too. So it's quadrant 1 and quadrant 4. For cosine, you're going to use quadrant 1 and quadrant 2. And his reciprocal, secant, quadrant 1 and quadrant 2. For tangent, you're going to use 1 and 4. But for cotangent, you're going to use 1 and 2. And this is the piece that you kind of have to have memorized. Now, that's a lot of Roman numerals and arc whatevers to memorize. I'm a pretty visual person, so I kind of memorized a little picture. So if you want to, I'm sorry, what?
Yeah, ours, it says that the arcsine and cosecant is quadrant 1 and 2.
Oh, yeah, it doesn't match yours because I typed it wrong last night. I apologize. I thought that this chart was in the same order as this other page of notes I was looking at, so I apologize. So it needs to match mine now. Sorry. So fix it. Sorry. Thank you, Tanner. So it's 1 and 4, 1 and 2, 1 and 4, 1 and 4, 1 and 2, 1 and 2. Thanks for bringing that up. Sorry about that. Yeah, I gotta fix that before next year. I apologize. Yep, fix that page. Everybody have the new numbers on their page? So they're all quadrant 1, And then it goes 4, 2, 4, 4, 2, 2. Whoops. Now again, like memorizing all of that is kind of a bit much for me. Like I do better if I can see something. So if you're that kind of person, I'd write this down. Draw yourself a little grid. We know our quadrants. We know that this is 0. We know that this is pi over 2. We know that this is pi. Do not call this 3 pi over 2. We're going to call this negative pi over 2. Here's why. Because all of those graphs I showed you, those domains, those ranges actually, are all limited. And so they're limited so that they're either between negative pi over 2 and pi over 2, or between 0 and pi. So that's why we don't call this 3 pi over 2, because it messes with the graph. So now, 1 and 4 is going to be sine and cosecant. 1 and 2 is cosine and secant. So it's sine, cosine, and then tangent, cotangent gets split. Tangent, cotangent. So this one's tangent, this one's cotangent. And you can remember it because cosine and cotangent are the same quadrants. Cosine and cotangent use the same quadrants. So this little picture is kind of what's always in my head, because it's hard for me to sort of memorize each of those intervals on their own, and it probably is for some of you too. Bless you. All right, so kind of keep this in your mind, kind of keep that out, and let's think about it. And we're going to start going through some examples. At the bottom. It says y equals arc sine of radical 3 over 2. Now, it's been a while since you guys have seen that. Remember, here's what it means. The sine of what angle is radical 3 over 2? So it's asking for the sine of what equals radical 3 over 2. Think about your unit circle. Think about your hand trig. 60 degrees. So if it's 60 degrees, what is that in radians? Pi over 3. And pi over 3, remember sine needs to be in quadrant 1 or quadrant 4. Is pi over 3 in quadrant 1 or 4? Yeah, so you're good. And that's your answer. All right, let's look at the next one. This is another way to write arc sine. I know it's been a while since you've seen it. This is asking for the sine of what angle equals negative a half. What's that going to be? If it was just a half, it would be 30 degrees, right? Or pi over 6, but it says negative a half. Let's think about our quadrants. All students take calculus. In the fourth quadrant, it's negative. Now, sine is also negative in the third quadrant, but they don't want answers to come from the third quadrant. It says fourth quadrant. You're not going to go all the way around and call that a positive radian. You're just going to say it's negative pi over 6. Okay? So these angles head this direction. So negative pi over 6. And that's going to keep it really pretty on that graph when you start graphing tomorrow and you have to graph in the right domain and range. Questions so far? Let's keep going. At the top, y equals arc cosine of 0. It means cosine of what angle is 0? When is cosine 0? Pi over 2. And remember, cosine has to be in the first and second quadrant, so we're good. Next one. The cosine of what angle is a half? Pi over 3, it's 60 degrees. If you are unsure about that, you can always double check yourself on the very back of the pink sheet. There's a gigantic chart that lists out everything so that you can look and say, okay, cosine is a half. So I go down cosine, I'm looking for a half, and it's right there at 60 degrees. It's pi over 3. Okay? Now be careful, though, on those negatives, because it's not going to say, like this one right here is not going to say negative pi over 4. It's going to say 7 pi over 4. So just be careful. For E, we have tangent of what angle is radical 3. And you're going to have to be able to do this without a calculator and without notes. So I'd try it really hard without the pink shade. 60 degrees, which is pi over 3, right? Good. Next one's tricky. You guys think on it before I say anything out loud. Whoops. Some of you guys already got there. We have cosecant, if that's too hard to kind of figure out, because it is a little tricky. I know that cosecant, if I flip this answer upside down, it's the same as whatever sine is. So the sine of theta is negative 1 over radical 2, which I know is really negative radical 2 over 2, right? That probably rings a bell for 45 degrees. Pi over 4. But that's a negative radical 2 over 2. So what do? Negative pi over 4. It's in the fourth quadrant. Questions on that one in particular? That one's a little trickier. All right, the last two, we're gonna get to use our calculator, and I believe it even tells you that in your textbook you can use your calculator. And it even tells you what mode to put it in, which is fantastic. So grab your calculators, go to mode, and make sure you're in radians. You guys see if you can figure out what y is. If x is negative 4, what's y? What's your calculator say? What do we type in? What do we do? Ah, what's happening? I forgot. All right. Secant, a lot of you guys are going to remember that's 1 over cosine. If you type in, we'll just type it in. 1 divided by second cosine of negative 4. What do you get? An error, because it's trying to flip an undefined fraction upside down, I think, which is a problem. So there's got to be another way around this. Can we also say, okay, so it's asking for secant of y equals negative 4. Instead of making this 1 over cosine, let's make this regular cosine, and let's flip this guy. Now do arc cosine of negative 1/4. What'd you get? There you go. That sounds much prettier. Does everybody see what happened? So if you need to write this down in your notes, in your calculator, to get this answer, you had to type in second cosine of negative 1/4. You had to flip the 4 upside down. Letter H says in degrees, so change your mode. And you guys see if you can come up with the answer. did the answer you get fall between the limits that are allowed for tangent? Remember, tangent can be in the first or the fourth quadrant. So it does, and don't forget, you need a little degree bubble. So that's degrees. You should get negative 75.81. How I got there was, I said, okay, they're asking me the cotangent of what angle equals negative 0.2528. Rather than change cotangent to 1 over tangent, I just changed it to regular tangent, and then I flipped this guy instead. So second tan, type this in, you get negative 75.81. Questions? Alrighty, your assignment's on the board. It says real number values means to use radians. Logan, did you have a question?
Are you stretching?